See, coming to operating systems, it is a systems course, and moreover, it has a lot of theory in it. One is theory, and other is problems. And in GATE, they mostly ask problems, and sometimes they even ask theory also. So, if you want to read some theory about operating systems, there are some good books. One book is Galvin, Operating Systems by Galvin, and other book is Tenenbaum. And as William Stallings is also there, but I don't really suggest that you refer it. Galvin, Tenenbaum, and there is one by Dhamdere. Okay, so but the best two books are Galvin and Tenenbaum. So if you read these books, almost everything is there. Then I'll tell you. Coming to the topics, whenever I teach any particular topic, at that point I'll tell you which textbook to read. Anyway, you need not read any textbooks. In case if you are interested in, if you have more time, and if you are interested in learning more, yes, definitely you could go for textbooks, but then first priority should be given to my videos. Okay, and that is about operating systems. And then coming to the way I teach operating systems, see, most of the theory will be provided in the material which I am going to provide you, and whatever theory that is already there in the material, I'll just explain you orally. And if you want, you could just keep on pausing the videos and take the rough notes, or everything will be there in the material which I am going to provide you. Either you completely follow videos, or you can read the materials, but then I suggest that you at least watch all the videos once and then read the material. That will be effective, because I will be covering more points in the videos than the mostly handouts. Okay, and then the way I teach it is, I'll take examples and then I'll explain the theory. Okay, so theory, I'll just not focus a lot of time on theory, only the essential parts I'll teach you. And for theory, just for theory, you might have to refer the books, textbooks, in case if you have time. Otherwise, just stick to my material and then videos, right? Yeah, now see this operating system introduction, and this introduction you can find in every textbook, any textbook. There is nothing special about it, but still I'll just explain you a few points. First one is, operating system is the interface between user and hardware. So we have the hardware means the CPU, memory, all these printers, all these are called hardware. Now there is hardware, we have the hardware, right? And then user is somewhere here. If you have to access the hardware directly, then user has to get into lot of code. He has to write lot of code even to execute a small function. For example, nowadays you are able to write a small C function using printf, right? If there is no operating system, if you have to directly interact with the hardware, then first of all you should write the program for everything. You cannot call printf, because printf internally makes a system call, right? And for the system call, operating system is going to provide you. Therefore, operating system makes it easy and convenient for us to use the hardware. See, without operating systems, many things, let us say you have to write 10 programs. In every program, you should write the code which will enable you to access the hardware first and then give it some commands, right? But then having an operating system, you need not worry about how to interact with the hardware. You can just say what your program should do, and operating system will take those commands, and appropriately operating system will generate the system calls. Okay, what is the system call is, for example, in your program you have written printf, right? And the corresponding functionality of printf is not actually in printf. It is done by the operating system in the system call write, right? So if you don't have operating system, you are supposed to write the entire code which is actually written inside the write. So when many people need the same functionality, same kind of functionality, instead of asking everyone to implement it, operating system is going to provide it at one place, so that users can directly use that functionality and need not bother about their implementation. That is how system calls are going to help. Did you ever think about how write system call or read system call, or at least printf is implemented? No, right? We just are guaranteed that you write this command and this action is guaranteed, right? So that kind of functionality is provided by operating system. You need not worry about the internal details. You just focus on your task, and everything else that you want is already provided by operating system. Therefore, it is a kind of interface, which means you need not do a lot of work in order to write a program. Most of the things which are required by this program are already implemented by the operating system, right? And now whenever you want to take any support from operating system, you are supposed to call something called as function call or system call. Okay, so here, okay, there is a difference between function calling and system calling. Anyway, we shall see it later, what is system call and what is functional call, and these things I'll talk about it later. But just remember that without operating system, it is very difficult to use hardware. People tried using it long back, but then every program has to write its own code so that it will interact with the hardware and then give it the commands. So obviously it is going to be a lot of time taking and inefficient. Even many people did the same thing, why don't you implement it at one place and call it many times, right? So that is how operating system is going to be an interface. And next one is resource allocator. What is resource allocation is when we have many people sharing the computers, right? Or when we have many programs running simultaneously, we are supposed to allocate CPU to one of them and memory to some of them and printers to some of them. So that is called resource allocation. So how do I allocate one resource to one process? Sometimes some resources are not shareable, right? In that case, what you should do is you should allocate it to one and then take it out and then allocate it to other one. Sometimes resources are shareable, then we can allocate all of them simultaneously. So this resource allocation, resource means anything like CPU or memory or printers or any device or any file, that is resource. And allocation means giving these resources to the process. And manager, it acts as a manager. Management means bookkeeping in the sense what is the resource allocated to which one and what are the free resources and what is the current capacity and how many people can I service further, everything. That is called management. Managing means they are going to manage the memory can be managed, like how much memory you have, how much is allocated, how much is free. And process means every program that has to run, for every program there will be a process created and then this process has to be managed, like what is the current states and all I'll tell you later. Shortly I'll talk about this process, leave it for now. And now files. So when we have many files, how are you going to see that the file system is consistent, which means even when many processes are accessing the same files, the data present in that should be consistent. And security, yes, security is important because when many people are accessing the same resources, some person will be allocated some resources and other people should not access this, or even at the level of processes also it is same, which means if a process is given some resource, then at that time someone else should not be able to access it, right? Therefore security also should be provided. Okay, and what are the main goals of this operating system is primary goal, which means main goal is convenience. So it is just to make it simple for the users to use it. So if you look at this DOS, disk operating system, convenience is not there, which means you might have to type everything. But if you look at this Macintosh systems, Apple, the convenience, their main focus is on convenience, which means it should be very easy for anyone to use it, right? So mainly operating systems, when you look at these mainframes and supercomputers, they need not go for convenience because people who use those systems are experts. In that case, efficiency will be used. Therefore, on mainframes and supercomputers, our main goal is efficiency. But then operating system is mainly used by the naive users at home computers or personal computers, where the main goal is convenience. So when I am talking about the personal computers, then the main goal is convenience and secondary goal is efficiency. We really don't want our computers to be efficient. We really don't need them to be efficient. If they could give us efficiency, it is fine. But then our main goal is make it simple to use the computer, because most of the people who use computers these days doesn't know much about hardware and software, right? They are just the end users. Then in that case, the main goal is convenience, secondary goal is efficiency. But in terms of these supercomputers and mainframes, the main goal is efficiency and the secondary goal is convenience, right? And there are various examples of operating systems which are used on various machines. Okay, now let's go to the types of operating systems. So the first operating system is batch operating system, batch OS. So what happened was long back, there used to be only a single computer to which everyone will be given access, and long back means in 1970s and 1980s, the computers used to be very scarce. Then what happened is they used to have one single computer which is called mainframe. Then everyone should give their programs to that mainframe, and in a queue they will put them all, and then the computer will pick up one after the other and execute them, and then later at some point of time users will come and pick them. Which means, see this, there used to be only one computer and all the jobs will be provided to this J1, J2, J3 like this, J4 by the users, and then they'll just not wait for the result, they'll just go away, and then after some point of time, after some time, some amount of time, they are going to collect the results. For example, if people have given J1, J2, J3, J4, then computer will take first J1, this operating system, whatever I'm saying, batch operating system, and then finish it and then produce the results and save it at some place. Then the user who has given J1 will come after some time and collect the results and they will leave, right? Similarly, next J2, next J3, next J4, likewise it will be doing it, right? But the problem with this bash operating system was, if the job J1 which has to be serviced is going to take a lot of time, which means the first job is going to take 10 days, then for all these 10 days all the other jobs will starve, right? And second thing is, if the job J1 or any of the jobs require input output, which means assume that this J1, okay, first before going ahead, processors require two types of time. One is CPU time and other is IO time, which means sometimes they want to use the CPU and sometimes they want to use the input output devices like printers, right, scanners and all that. Now when you have CPU and IO times involved in a process, the process which has more CPU requirement will have more CPU time, and the process which has more IO requirement will have more IO time. Now if a job is here, if a process requires less CPU time and more IO time, then what happens is CPU will be executing this job J1. Let us say job J1 is the first process which requires only little amount of CPU time and more IO time. Then CPU will be taking this job J1 for some time, and after that it will push it to the IO device. Fine. And now while J1 is at the IO, CPU should have executed J2, J3, J4, but then according to the rules of batch processing, whoever gives their job first should finish it, then only other jobs will be taken up for processing. Therefore, even if the CPU is idle, even when the job which is selected is doing some IO work, even when CPU should have taken other jobs, it will not do that. That is why the efficiency is less, the throughput is less. So one thing is there is starvation, and second thing is starvation provided that J1 is going to take a lot of time, and the next one is efficiency is very less, right? And now it is not even interactive also. Interactive means a user cannot submit a job and then wait for the response. For example, if you have some programs which will continuously ask for the user input, for example like press 1 to do this, press 2 to do this, and if you give it to the job processing, then what happens is, if that job which you require to interact, which you want to interact, happens to be, let us say, J10, right? Then until all these jobs are over, your J10 will never be processed, right? Therefore it is not really useful for interactive applications, right? So what happened is, people, they used it, but then long back, currently no one is actually using batch operating system. Yes, they are using it, but really in the supercomputers and then the mainframes. So if you have any supercomputer which is having like this, what I can tell you is, if you have a supercomputer in a college, and if many people wants to access it, then what they do is they'll get the accounts, and every account, using an account you can submit a job, but then your job is going to sit and wait in the queue, and therefore after all the jobs which are given ahead of you, after all of them are over, then your job will be taken. But then recently there have been modifications done in such a way that I'll talk about it. In the sense, the other things are used here, right? And next one is multi-programming. So multi-programming means it is just an extension to this batch processing. So here, whenever a job is wants IO, whenever it goes to the IO device, right, then CPU can actually take other job and process it. That is called multi-programming. So using multi-programming, CPU will be used efficiently as long as there are jobs which doesn't need any IO. CPU will always be busy. In the sense, if first job requires IO, it will go to the IO device, then it will pick up the second job, and if the second job also turns out to require IO, then the second job will go to the IO device and it will pick up the third job. So using multi-programming, the advantage is you need not actually keep the CPU idle. CPU will be busy all the time, right? So using this, efficiency has been improved, which was not there in the batch OS, right? And next one is multitasking operating system. Multitasking operating system is just an extension to multi-programming, where instead of providing access to one particular job and then finishing it off, multitasking does it. So there is actually a slight problem in the terminology. Some textbooks say what I am teaching you, and some textbooks say completely different thing. In some textbooks, multi-programming and multitasking both are same, and in some textbooks there is a slight difference, right? Anyway, they are not supposed to ask you the difference between these two in GATE, right? So I am following some textbooks in which they have discussed about these two separately. In some they are actually combined, right? But anyway, the difference what is mentioned by some authors is, it seems that multitasking means you could give J1, J2, J3, J4 like this, J1, J2, J3, J4 some processes, then CPU will choose J1 for some time, then again J2, then again J4, then again J5, which means CPU will be multiplexing among all the jobs without even completing anything, right? So that way interactiveness can be improved, which means if a user is waiting for the output to be produced, then user need not wait for a long time. The reason is his process will get a chance periodically, therefore it will be interactive. But earlier, now either you take batch operating system or multi-programming operating system, there is nothing like preemption. Preemption means when a job is already performing well in CPU time, they will not pull it out. But then in multitasking, the CPU will be pulled out using some constraint, and then it will be in a multiplexing order like round robin. We shall discuss about it, but then from now on, let's think that multitasking and multi-programming both are same, because in some textbooks they never talk about multitasking at all, and in some textbooks they combine them, right? So anyway, the main difference between batch operating system and the multiprocessing or multitasking is, in batch operating system there is no interactivity, and in the batch operating system there is starvation, and moreover a starvation is here itself, but then the main problem is CPU will be idle some of the time. Either you use multi-programming or multitasking, the CPU will not be idle. And multi-programming actually with preemption. Preemption means if you could allow the processor to stop a process forcefully and then start the other one, then that is called preemption. So if you have the preemption facility, multi-programming is nothing but multitasking, right? Fine. And from now on, instead of using multitasking term, I'll be using multi-programming, which actually contains even multitasking as well. Now this batch operating system is different, and these two are similar, and the next one is called multi-processing. So multi-processing is again different, in the sense, instead of having one CPU, you will have lots of CPUs in the same computer. CPU 1, CPU 2, CPU 3, right? Now the advantage of having these many CPUs is many jobs can be processed simultaneously, which means parallelism is improved in multiprocessing. It is like this. Recently, okay, what is the difference between having multi-computers and multi-processing systems is, in a computer, in a single computer, if you have many CPUs, then that is called multi-processing environment. It is actually similar to having multi-computers, many computers, but then the concept is, this concept is less costly, in the sense you need not buy everything. You have to just buy the CPUs, and everything will combinedly use the memory and the file system, and everything will be shared. Therefore the cost of it is less, but the efficiency is more. At any time, in this case, if you have three processes, three jobs will be, three processors, you have three jobs which are executing parallelly, right? So what is the advantage of multiprocessing is the throughput can be improved. Throughput means the number of jobs which are going to be finished per unit time. I'll talk about throughput again, but then here the point is it will be faster in the sense, obviously you can see it, right? If the work is done by three parallelly, it will be fast, right? Fine. And then moreover, it is reliability is also increased. What is reliability? If one of them fails, the jobs will be scheduled onto the other CPUs. But then if you look at the other computers, other programming environments where you have only one CPU, if one of them fails, you cannot really access the other one, right? And recently almost every computer is multi-core. Multi-core means, like you might have heard about it, dual core means 2 CPUs, quad core 4 CPUs, octa core 8 CPUs, right? Therefore this multi-processing is a popular environment now. Anyway, multiprocessing can be combined with multi-programming, in the sense, even if you have many CPUs, each CPU can be used any way you like. Either you can use it as a batch processing system, or you can use it as a multiprocessing or multitasking system, which means the the first CPU can be given many jobs parallelly, and each job can work at its own. It can process each job and then go to the next one, or it can go multiplex, right? Fine. And then there are real-time operating systems which are not really important for our GATE syllabus, for coming to our GATE exam, but they just it is just worth knowing about them. Real-time means you will be given some jobs, and the jobs will be having some deadlines, and now you are supposed to finish the jobs in those deadlines. That is called real-time. So what is the main difference between others and this one is, here we have strict deadlines. You are supposed to finish the job at that. Otherwise, if you don't finish it, there will be a huge loss incurring, or even if you produce the result after that time, it will completely be useless. For example, in military applications, if you want to drop a missile, that missile has to be dropped exactly with a lot of precision, right? So even if you miss out of a beat, then it is going to be harmful, right? So like that, real-time applications use real-time operating systems where timing is everything, right? So anyway, we don't need it for GATE. So for GATE, the most important part is multi-programming. So which also includes, by multi-programming I mean multitasking as well. So what I mean to say is, there will be a single CPU to which many processes will be scheduled, and all these processes can be executed in any way, either with preemption or without preemption. I'll talk about it shortly, what is with preemption and without preemption. Okay, this is about the introduction to operating system. So in operating system, we have various topics like how is memory managed, and how are process managed. And by process management, and I mean there are various things, like when many processes want to communicate with each other, right? Then we need to synchronize them. That is called synchronization. So we have synchronization, and then we have file management, and then we have security, right? So they are the main important modules you might have to talk about operating system. So we shall discuss everything. So but then this is the brief overview of operating system. Okay, we shall look at the concepts, one by one. So when I'm teaching some concept, maybe you might not understand some of the words which I talk, but once you finish all the entire course, it will be very easy that everything will fall in place. So even if you don't understand anything when I'm teaching it, just keep on watching it, and act as if that video never happened, and just go ahead to the next one. So at some point I'll be talking about the terminology which I used in earlier videos. Therefore everything will make sense by the end of the course. So even if you don't understand anything while I'm teaching, keep on going, don't stop watching, right? By the end of the course, everything will make sense, even if it doesn't seem to be meaningful earlier. Okay, fine.